Oumuamua, this strange object that was discovered 2017, don't quite match what you expected, and you're trying to find an explanation. It moved too fast to be bound to the sun. Very first object that we have found coming to us from interstellar space, from other...
In July 2025, NASA's Atlas survey in Chile spotted 3I Atlas, only the third confirmed interstellar object after Oumuamua and Borisov. For Avi Loeb, it's proof he was right all along. These visitors can be risky. And this time, we saw it coming early. Discovery details. The discovery of 3I Atlas was quiet and almost no one outside the astronomy world noticed at first. On the 1st of July 2025, NASA's Atlas Survey telescope in Chile picked it up during a routine scan of the sky. There was no big press release or wave of headlines. It started like so many other small space object discoveries, a faint dot of light, marked and saved for later study. At the start, 3I Atlas looked like an ordinary comet from our own solar system. Through the telescope it showed a soft glow and a thin tail. That suggested it was made of ice and dust that was slowly turning into gas as it got closer to the sun. For the scientists tracking it, this was normal. Every year they find many objects that seem similar. Most are watched for a short time and then fade into the background once their paths are understood. But this object moved in a way that felt unusual. Over the next few days the tracking data showed its path was not like the loops planets and comets usually follow. Instead it was moving on a hyperbolic path, a stretched curve that would take it past the sun only once before it headed back into deep space forever. That told scientists it had come from another star system. With this, 3I Atlas became only the third confirmed interstellar object after Oumuamua in 2017 and Borisov in 2019. The way this discovery was received was very different from those earlier ones. Oumuamua became famous almost overnight. It led to debates all over the world when Avi Loeb suggested it could be an artificial object. Borisov also made headlines as a true comet from another star, with a bright and active tail that caught the eye of many observers. 3I Atlas did not get that kind of attention. The timing played a role. When it was first seen, many scientists and news outlets were focused on other space events. It also looked fairly normal compared to the dramatic shapes and activity of the earlier interstellar visitors. Still, this find has one important advantage. We saw 3I Atlas much earlier in its journey. That means there is more time to watch it closely and gather information before it disappears into the dark again. For people like Avi Loeb who warn about the dangers of such objects, that extra time is a big win. But finding 3I Atlas early was just the beginning. What scientists discovered about its speed and path would change everything. Physical characteristics. 3I Atlas is moving through space at a speed that is hard to imagine. It is traveling about 60 kilometers every second. That adds up to more than 216,000 kilometers in an hour. This is roughly twice as fast as Earth moves around the Sun. With that kind of speed, it will pass through our solar system in only a few months before heading back into the deep darkness between the stars. Its path is hyperbolic. This means it is not going in a loop around the Sun like planets or normal comets. Instead, the path is a stretched curve that shows it came from somewhere far beyond our solar system. Long ago, something must have thrown it out of its home star system. Now it is on a single pass through our part of space. The closest point to the Sun, called perihelion, will come between the 29th and 30th of October 2025. At that time, it will be moving at its highest speed and showing the most visible activity. This will be the best chance for scientists to study it in detail. When astronomers first saw 3I Atlas, they noticed it had features that looked like a comet. It showed a faint hazy coma, which is a cloud of gas and dust around the solid core. There might also be a small tail forming as sunlight warms the surface. That heat turns ice inside the object into gas, which escapes into space. This process is called outgassing and is very common for comets. It also happened with another interstellar visitor, Borisov. Right now, estimates suggest 3I Atlas could be as wide as 20 kilometers. Many scientists think it is probably smaller. Measuring the size is tricky because the glowing coma can make it appear larger than it truly is. As it gets closer to the Sun, its brightness and activity will change. That will help astronomers make better guesses about its actual size. The makeup of 3I Atlas is still a mystery. We know it is releasing gas, but we do not yet know which chemicals are present. Scientists plan to use a method called spectral analysis. This means splitting its light into different colors and looking for patterns that match certain materials. This can reveal if it holds water ice, carbon compounds, or other interesting substances that might give clues about where it came from. With 3I Atlas racing toward the Sun at incredible speed, the question remained, how does it compare to the other mysterious visitors we've seen before? Comparison with previous interstellar objects. 3I Atlas is only the third confirmed visitor from another star system. To understand its place in this rare group, it helps to look back at the first two. The first was Oumuamua, spotted in 2017. It had a long, narrow shape that some compared to a cigar. Unlike most comets, it showed no tail or hazy coma. Even more puzzling, it sped up slightly as it moved away from the Sun. This extra push could not be explained by gravity alone. Some scientists thought it might be caused by gas escaping from the surface, but no gas or dust was detected. Others, like Avi Loeb, suggested it could even be an artificial object. The mystery remains unsolved. Unfortunately, Oumuamua was already on its way out of the solar system when it was discovered, so there was no time for a proper, detailed study. The second was Borisov, found in 2019. This one behaved much more like a typical comet from our own solar system. It had a bright coma, a clear tail, and a chemical makeup similar to comets we already knew. Observations showed it contained water ice and carbon-based molecules, which supported ideas about how planetary systems form in other parts of the galaxy. Because Borisov acted like a normal comet, it did not cause the same level of debate as Oumuamua, but it still gave scientists valuable data. 3I Atlas appears to fall somewhere between these two earlier visitors. Like Borisov, it shows comet-like features, including a faint coma and possible tail. However, the activity so far seems weak, with only a small amount of gas and dust being released. It does not have the extreme, unexplained behavior of Oumuamua, yet it is not as active and bright as Borisov. The most important difference is timing. 3I Atlas was spotted months before its closest approach to the Sun. This gives scientists a full observation window, from early approach, through perihelion, and into its departure. That is a huge advantage over Oumuamua, which was already leaving when it was noticed. Early detection also means more chances to gather detailed images, track changes in its activity, and study its composition using powerful telescopes. Unlike the puzzling visitors before it, 3I Atlas offered something completely new, time. But how did we suddenly get so good at spotting these cosmic travelers? Observational timeline and opportunities. The discovery of 3I Atlas early in its journey gives scientists a rare and valuable chance to watch an interstellar object from start to finish. Because these visitors travel so fast, they usually appear and vanish before we can study them in depth. This time, the timeline is clear, and every stage brings its own opportunities for learning. Right now, in August 2025, 3I Atlas is already visible to large professional telescopes and some powerful amateur setups in the southern hemisphere. Through August and September, it will be in the best position for long observation runs. These months are perfect for collecting images and tracking its brightness to see if activity increases as it gets closer to the Sun. Early readings on its coma, tail, and rotation rate will help build a complete picture of its behavior. The most exciting part of the timeline comes in late October 2025. Between the 29th and 30th, 3I Atlas will reach perihelion, its closest point to the Sun. Around this time, it will be moving at its fastest speed and could show peak outgassing.